So next step is step number 4. That is design strength due to block shear. So for this we just need to draw a diagram. So this is your section 100 by 75 by 6 mm, and this is your gusset plate. Now you have this tensile force. Because of this you need to just design at this part what is the force coming out to be and what is the force coming out to be. So let us consider moment. So P1 multiplied by 100 will be equals to 230 multiplied by 100 minus 30.1. So this is 30.1, which is actually this one. This is 30.1. This you will get it in your steel table. What is the distance of this CG? So from here you can be able to calculate P1. And this is 160.8 kilonewton. Similarly, we can get P2, which would be equals to total is 230 minus 160.8. The total load, P load, is already given in the problem, and so therefore this would be equals to 69.2. Now we can go to the clause number 10.5.7, which is on the page number 79. Where you will get So this is the clause number 10.5.7.1.1. So here you will get strength of the fillet weld, that is FWN by gamma MW. So this we can calculate. So first of all, strength of 4 mm weld, which would be equals to this is TT multiplied by 0.462 FU. And this TT, that is the throat thickness, that is 0.707 multiplied by, you are going to use 4 mm weld, so multiplied by 0.462 multiplied by FU is 410. So that is it. It is 0.462, it is directly considered because that is 1 by root 3, or you can just simply consider this as FWN, which is equals to FU by root 3, this value. So FWD, which is equals to FWN and divided by gamma MW. So gamma MW, what we got is from page number 30, table number 5, and that is equals to gamma MW, which is for the welding 1.25. So if you just multiply it, you will get 0.462 directly. So finally you will get, or I can just simply write down here, FU by root 3 and this is divided by 1.25. So that is your FWD. So therefore here FWD, if you calculate, you will get it around 530.37 kilonewton per mm. Now we can calculate the effective length of the weld on hillside. So now effective length of weld on hillside, what is equals to, let us say L1, which is equals to P1 divided by strength of the weld. So P1 you already got, that is 160.8, will convert into Newton, and divided by strength of the weld you got 530.37. So L1 you will get it around 303 mm, while L2 would be equals to similarly P2 divided by strength of weld. So P2 you got 69.2. We'll convert in terms of newtons, so we'll get divided by 530.37, and that is 132 mm. So now we can say total welded length. So therefore total weld length would be equal to addition of 303 plus 132, that is 435 mm. Now we need to calculate block shear. So for that again we just need to go to the page number 33, and where you will get this block shear as TDB1, that is clause number 6.4.1. So actually this is already given for the bolded connection, but if you just look at here for the block shear strength shall be checked for the welded connection by taking an appropriate section in the member around the end weld. So if we just consider here, this is the calculation of block shear strength TDB, that is AVG Fy by root 3 gamma mo plus 0.9 ATN into Fu by gamma m1, and similarly this again TDB, another TDB 0.9 AVN Fu by root 3 gamma m1 plus ATG Fy by gamma mo. And the next page you will get what exactly that AVG and AVN, that is minimum gross and net area, while ATG and ATN, that is the minimum gross and net area in the tension. This is in shear. So we will calculate that. First of all we can calculate, which can write down from clause 6.4.1 page number 33. So we have here AVG, which is equals to AVN. This is equals to total weld length multiplied by thickness. So total weld length multiplied by thickness. So weld length, this is 435 multiplied by thickness, that is 6 mm. So here you will get 2610 mm square. Similarly ATG, which is equals to ATN, and this is equals to the connected leg length, that is of 100 mm multiplied by 6, so this is 600 mm square. And we know this is, there are two formulae for calculation of block shear. So we'll go ahead with the TDB1. So TDB1, which is equals to AVG into Fy by root 3 gamma mo plus 0.9 into ATN into Fu by gamma m1. So here you will get it around, if you just calculate AVG, which we know that is 2610 multiplied by Fy, that is 250, root 3 into gamma MO, that is 1.1, plus this is 0.9 into ATN, that is 600, multiplied by 410. So instead we'll just write down here, this is 2610 multiplied by 250 divided by root 3 into 1.1 plus 0.9 into 600 into 410 gamma m1, that is 1.25. So we'll get here 519.7 kilonewton. So similarly we will calculate TDB2 out of these two, whatever is the minimum that is to be considered as your block shear. So this is 0.9 AVN Fu by root 3 into gamma m1 plus ATG Fy by gamma m1. So this is 0.9 into AVN, you got it here 2610. Fu is 410 divided by root 3 into gamma m1, that is 1.25, plus ATG, that is 600, multiplied by this is 250 divided by gamma MO, that is 1.1. So this is around 581.6. Out of all the strength, whichever is the minimum one that is to be considered as a tensile strength provided. So therefore tensile strength is equals to 230.7 kilonewton out of all the strength we have calculated. So we got the length of, that is 303 mm. So this is actually 303 mm. And this is 132 mm. This is how the length you will get.